Now, in the unit circle, the other thing that's important is that the radius is equal to 1. That's hence the name unit circle. So R equals 1. Got my little dot there. It looks like an explanation. R equals 1. So now, if you refer back to, and you remember your trig functions, we said that the sine of theta is equal to y over r. If r is 1, then that simplifies to just y. So in the unit circle, sine of whatever your angle is just the y value. Now this only works in the unit circle. Anything outside of the unit circle, you have to keep your y over r. So the cosine of theta was x over r. Now, since r is 1, that simply becomes x. The tangent is still y over x. That didn't change. The cosecant is 1 over y now because it's the reciprocal of y. The secant is 1 over x because it's the reciprocal of the cosine. And the cotangent is still x over y. Okay. So on our unit circle, if we can find an xy value, we know directly from just looking at the circle what the cosine is and what the sine is. It's just the x and y values. So, first thing we're going to do is we're going to start with our quadrantal angles. New word. You need to learn that one. Write it down. Quadrantal angles. The quadrantal angles are any angle where its terminal side, where it lands, is on one of the axes. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back around to 360 degrees. You could go as many times around as you want, but those are the main ones that you need to know. Okay. So, got your unit circle handy. This point right here at 0 degrees, if r equals 1, what is my x value?
R equals 1.
X is 1. If r is 1, then right here on 0 degrees, my x value is 1. How about my y value on that point?
0.
0. Okay? Because I didn't go up and down. If I was plotting that point, all I did is I counted 1 this direction. I didn't go up or down anything, right? Okay, so now think about your coordinate axes up here at 90 degrees. Now, what's my x value?
0.
0.
Your y is 1.
And my y is 1. X is 0. Okay, now I come over here to 180 degrees.
Negative 1.
My x value is negative 1 because I went 1 in the negative direction. And my y value is 0. And when I go down to 270, my x value is 0. And my y value is negative 1. If I come back around to 360, it's just the same as 0. Okay? So the sine and cosine of 0 and 360 are going to be the same, which makes sense because they have the same referencing. Any questions about that part of your unit circle? Everybody knows where those numbers came from because that's what's going to make this whole thing make sense. Okay, so now that you have that written on your unit circle,
What about the other?
we're going to get to them in a minute. Those are the right, straightforward, easy ones right away. So we're going to use that to find the 6 trig values of 270 degrees. So we'll start with the sine of 270 degrees. Well, we just said in the unit circle it's just y. So here's 270 degrees right here. What's my y value there?
Y value is negative 1.
Negative 1. negative 1. Okay? Cosine of 270 degrees is x. So my x
Oh, okay.
is 0, so that's going to be 0. The tangent of 270 degrees is y over x, or sine over cosine, so that's negative 1 over 0. If I divide by 0, that is undefined.
Okay.
If the zero's in the bottom, it's undefined. Now, these other three are just the reciprocals of those. So let's go cosecant of 270 degrees. The reciprocal of negative 1 is 1 over negative 1, which is just negative 1. The secant of 270 degrees is 1 over the cosine, or 1 over x, so 1 over 0, which is undefined. And the cotangent of 270 degrees is, instead of negative 1 over 0, now 0 over negative 1. So that's just 0. When it's 0 in the top, it's 0. When it's 0 in the bottom, it's undefined. Okay, questions on this one? Now, just a quick check for yourself. If you have one undefined, you should have 2, because everything's got a reciprocal. So if you do all 6, that's a quick check for yourself. And if you have 0 on one side, you should have a 0 on the other side. Okay, any questions about that? Okay. So now, we talked a little bit yesterday about reference angles. We're going to talk some more about reference angles, and part of your assignment today is going to be actually finding some. So, 140 degrees, I want to find a reference angle. You're going to remember that a reference angle is always with the x-axis. It's always formed with the x-axis. So what I'm going to do is I'm going to draw a picture. Here's my axes, x and y. 140 degrees. What quadrant does that land in?
That'd be in quadrant 2.
That'd be quadrant 2, because it's more than 90,
But less than 180.
but less than 180. Okay, so it's going to be right here. This is 140 degrees. You always form the reference angle with the x-axis. So if I went all the way over there, it'd be 180. So to find that reference angle, I'm going to say 180 minus 140 gives me 40 degrees. So my reference angle is 40 degrees.
Can't you just go 260? Can't you just go 360? Or no?
That's going to be the easiest. Another thing I want you to know, reference angles are always between, if it's not a quadrantal angle, it's always between 0 and 90. They're always positive. That's how we relate these to our right triangles. Okay, so a reference angle is either between 0 and 90, or if it's in radians, it's between 0 and pi over 2, because that's 90 in radians. Okay, so let's look at the next one, 260. Which quadrant's that one going to land in?
Quadrant 3.
Yep, it's more than 90, more than 180, less than 270. So it's going to be in quadrant 3. Now remember again, always the reference angle goes back to the x-axis. So now I want to know how much more than 180 it is. So I say 260 minus 180.
It's always minus 180.
Not always. If it's in quadrant 2 or 3, it's 180. Okay, we're going to talk about the ones on the other side, 1 and 4 here in a minute. So this one's 80 degrees. So if it's in quadrant 2 or 3, you always are subtracting from 180, and it's always positive. So you just adjust your subtraction as appropriate there. Okay, so 300 degrees. We'll look at a fourth quadrant now. is more than 270 but less than 360, so he's going to land right in there. Now this time it's always with the x-axis, so this time it's going to be on the other side. So if this is 300 degrees, in order to find the reference angle, I'm going to have to subtract from 360. So I say 360 minus 300 gives me 60 degrees. So if you're in quadrant 4, you're going to be relative to the 360 degrees, or the 0, as the case may be. Now, you notice I didn't do an example from quadrant 1, because that's going to be just your, if it's a positive angle, less than 360, it's just going to be that angle. Okay? Questions about those? Okay. Well, how about when it's more than 360 degrees? Then it's negative. We'll throw some other twist in there. Okay, so again, draw the picture. Negative, I'm going to be going the other direction. In order to figure out how much more than 360, I'm going to add 360 degrees, and that's a negative 10 degrees. So I'm going to go negative 360 plus another 10 degrees. So I'm looking at this angle right here. Got my arrow. You got to remember those. You leave them on. Okay. If this is my reference angle, how much is it going to be? 10. Because I went 10 past the 360. It's now, the reference angle is never negative. So the reference angle is between 0 and 90. If I'm drawing the actual angle, it would be negative. But the reference angle is always positive. Okay, questions on those? Now I got to throw one in here with the radians because you guys need practice with that. So let's play with the radians. Okay, I want to graph 5 pi over 3, and it's not degrees, it's radians. I need to get rid of my little degree sign here. Okay, so draw my xy axis. Okay, 5 pi over 3. Now the first thing that I would do here is I notice it is more than 1 pi because 5 is, it's an improper fraction. So then I need to compare it to 2 pi because 2 pi goes all the way around. So now if I want to write 2 pi with the same denominator as this one, in order to compare them they have to have the same denominator. I'm going to write 2 pi as 6 pi over 3. Everybody knows how I got that one? Multiply top and bottom by 3, but this is 2 pi over 1. Yes? Okay. So if 2 pi is equal to 6 pi over 3, now I can compare it. 5 pi over 3, is that more than once all the way around? Well, it's less. How much less? So if I take 6 pi over 3 minus 5 pi over 3, that's 1 pi over 3. Okay, so that's going to go, oh, it's positive, yeah. So it's going to go that far around.
Pi over 2 is 90 degrees.
Pi over 2 is 90.
So pi over 3.
Pi over 3, this way is going to be a little less than 90. It's pi over 3, 1/3 is less than 1/2. So it's going to be in that quadrant. Now, my reference angle.
Shouldn't it be in the first quadrant?
Yeah, halfway around is pi.
It's pi over 3.
It's 5 pi over 3.
Well, why do you figure out pi over 3?
Because that's how far it is. That's going to be my reference angle. Okay, that's how far it is from all the way around. Okay, so my reference angle here is going to be the pi over 3. So it's going to be related to either 2 pi or pi, depending on which quadrant it's in. Just like it's 360 or 180, depending on which quadrant. Okay, that makes sense for finding angles. if you can draw the picture of them, you should be able to figure out the reference angle. You've been practicing with pictures, so you should be getting good at that by now. Okay, so now we're going to get back to this unit circle. We're going to fill in another part of the unit, so we're going to kill two birds with one stone. We're going to fill in another part of the unit circle, and then we're going to use it to evaluate the cosecant of 17 pi over 6. So the first thing we need to do is figure out what's the reference angle for 17 pi over 6. So we got to make a picture of it. Now, 17 pi over 6. Now I want to compare that to 2 pi. If I put 2 pi as a fraction over 6, what's the fraction? 12 pi over 6. 2 times 6 is 12. So 12 pi over 6 is all the way around. That's 2 pi. So if it's obviously more than once around because 17 is more than 12. And it's then 5 pi over 6. Okay? So if I draw this picture, I want it big enough that I can write in it because I got a lot of stuff to put in here. I'm going to go all the way around once. Then 5 pi over 6 is going to be almost to pi, right? Because 5, 6 is just a little less than 1. And how much is left to get to pi?
3 pi over 6.
Pi over 6, because pi is 6 pi over 6 minus 5 pi over 6 gives me pi over 6. Okay, so my reference angle is pi over 6. On your unit circle, it's labeled as 5 pi over 6. So you can find that on your unit circle. All I did was I just graphed 5 pi over 6 is right here. Look on your unit circle, it's right there. Okay, so your reference angle is pi over 6. Because if I go another pi over 6, I get pi. That's what I did here.
So how many you got 17 from?
We did. Okay, it's all the way around once, and then another 5 pi over 6. So we're finding the reference. Now, here, you're going to use you either need to have that 30, 60, 90 triangle in your head and remember how it works, or you need to pull that out, because that's what we're going to use right now. Because pi over 6 is what angle in degrees? 150. Well, 5 pi over 6 is 150. Now my reference angle pi over 6 then is 30. This creates a 30, 60, 90 triangle. Now, since this is a unit circle, so I want you to put this in the context of your unit circle you got in front of you. I want to figure out what this point is, the x and the y. So I'm going to find the legs of the triangle, the x and the y. My radius is 1, because that's how we define a unit circle. So that's my r. In a 30, 60, 90 triangle, if I know the hypotenuse, how do I find the short leg? On your picture it says 2a for the hypotenuse and a for the short leg. Okay, that's going to be the long leg. We're going to get to
Divide by 2.
You divide by 2. So if this was 2a, this would be just a, so I have to divide by 2. So the short leg is a half. Okay? Then to find the long leg, I take the short leg times root 3. So root 3 times 1/2 is root 3 over 2. Now I'm going to put it in context of my coordinate system. In the x direction, I went a negative root 3 over 2. In the y direction, it's a positive 1/2. So the point here with that 5 pi over 6 on your unit circle is negative root 3 over 2, 1/2. Here's your x value, here's your y value. Remember, y is the sine. So your sine is 1/2. Your cosine is the x value. It's root 3 over 2. We are asked to find the cosecant. Cosecant is 1 over the sine, right? Or 1 over y. So the cosecant of 17 pi over 6 is 1 over y, which is 1/2. What is 1 over 1/2? Just a reciprocal. Now, we just did the hard part. If you have the mean circle all filled in, it's pretty easy. All you have to do is bring this out. Okay, which I'm going to give you that in just a minute. Okay, I'm going to fill in one more for you. I'm not going to go through as much detail on this one. I'm just going to tell you what it is. And you're going to relate it to a 45, 45, 90 triangle. I got to erase some because I got to get back here. Cosine of negative 225. Where's that one going to land?
Quadrant 2.
Quadrant 2. What's its reference angle? From here to here, 45 degrees. 225 minus 180 is 45 degrees. So that creates a 45, 45, 90 triangle. If my hypotenuse is 1, then 1 over root 2 is my length of both of my legs.
Hypotenuse is 1 root 2 over.
Well, okay, the hypotenuse is a root 2. If it's 1, then you say that 1 equals a root 2. To find out what a is, where a is the length of a leg, you divide by root 2. So a is 1 over root 2, which is root 2 over 2. That's both my x value and my y value. In this quadrant, the x is negative, the y is positive. So this is a negative root 2 over 2, positive root 2 over 2. That's your x and y value. If this is your x value, what is the cosine of negative 225 degrees? What's the x value? Negative root 2 over 2.
So is that the point?
So x value is just, so the cosine is negative, yep, it's just a point.
What is the difference in plus negative?
It's just a negative. Let me put myself in. Cosine of negative 225 is negative root 2 over 2.
Yeah, but
So if it was positive, it would still be like the same thing.
So if
positive
it was
225.
So if it was positive 225, you'd land in the third quadrant.
So it's different. That's
So
not the
points
point.
would be the same, but the signs would be different.
Those would be,
So then the x would be negative and the y would be negative.
so it would be negative root 2 over 2.
It'd be, so down here it would be negative root 2 over 2, positive root 2 over 2.
How would it be positive? Still
Or negative.
down.
Nope, you're right. Negative, negative. So, I have a nice picture for you to fill in the blanks. I'm not going to make you figure them all out.
This is kind of a-
So, right here is what you need. I want you to know where they come from. But this is, that's enough. I'm making as big as I can there. That's what it's going to look like. You can fill in the blanks on the rest of them. They're all based on either a 30, 60, 90 triangle or a 45, 45, 90 triangle.